What's up guys, Daniel here. In today's video I'm going to be showing you how you can create a letter pickup system in Godot. So as you can see here in this demo, I have this little letter here laying on the table, and when I press a button it goes in front of the player and he can view it, see some text on it, put it back down, and while he's looking at it he can only move his camera, he can't move around. For example, I have another letter here. Here you can also see the text. So as you can see here, I typed in the text, and in this other one there is a picture on the text. So this is a image that I have put on the mesh, and the other one is done with a control node. So let's get into it. How can you implement something like this in your game? So let's look at the code. Let me just see, I'm recording. It happened to me once that I started recording, but I thought I started recording, but I actually didn't. Realized it about 5 minutes into the recording. Anyway, so for this setup you need of course some kind of letter that will be that the player will be able to pick up. For this I created a letter scene in 3D with a Node 3D parent or root node. In it I have a mesh instance, which is the paper itself. I've set the dimensions of it to be an A4 paper, so if you also want an A4 paper you can just copy these dimensions. I also added some subdivision into it because of a shader that I'm using. This might not apply to your game. Going on, we have this. Well, you need some kind of interaction system. I have one interaction system in my game. I won't go into it right now. If you want to, I can make another video about it. And then we have a sub-viewport. This is for the cases when we want to display, well, basically a control scene on the paper. If you don't know, control scenes in Godot look like this basically, where you can create these like 2D UI scenes with text, borders, and all of that stuff. So let me just show you. This letter has some export variables that I've set. It has a text. If I want to, type in some kind of text that will appear on the letter, and we also have this control scene export variable, and this means that I can pass in any control node that that control node will be used as what will basically that control node will be displayed on the letter, and how this is implemented. And we also have a texture in case we want to display a texture instead of a control node. How this is implemented, let's see. So as I said, we have our export nodes, and if you don't know what this tool is, it's a very useful little thing that you can do in Godot. Basically, if you add this line in the very first line, this add tool, this will be able to run in the editor. So for example, if I change the texture, let me find the picture. So if I change the texture, for example, I have this newspaper. If I change the texture here, it will automatically update in the editor, and I don't have to run the code again to see the changes. This is a very powerful little thing that you can do in your script. And you can check if you're in the editor or not by checking this variable. So if you're in the editor, this will be true. If you're running the game, this will be false. So let's keep on going. We have our different kind of export variables, and then in the ready function we take our, well, first of all, if we have a texture, then if you use a shader, you would do it like this. If you use a simple what do you call it, the other one, the material override, the shader material, not the shader, the, what do you call it? Let me see. The standard material. If you use a standard material 3D, it might be a bit different, but basically you set the albedo texture as the texture. If we have some kind of scaling, I also have a scale export variable which you can set. We also set the scaling, and if we have a control scene, then we set that. And the way I've displayed a control scene on a mesh is with a sub viewport. So what this does, it captures a certain area of the control node and displays it on the mesh in simple terms. And to do this, let me just show you as an example. To do it manually, you would need to assign it a viewport texture. But since we're doing this from code, first of all, of course, we instantiate the control scene. So we need an instance of it which we can assign to the material. Then we set the text of the texture of the control instance, so what we want to be displayed. Then we add as a child to the subviewport this control scene. So how this subviewport works is that if any child it has, it will basically display it on this viewport. And then we set basically what I tried to demonstrate here manually. We do this, we set a viewport texture. So we do this, we basically select this viewport and set it as a texture, but from code. So we take the mesh instance, the material override, and set the shader parameter if you're using a shader. We set the albedo texture to a new, you can do it like this. You need the path of the subviewport here, but you can just fetch it from the subviewport itself. You don't have to hard code in, for example, like something like this. Let me just show you. You don't have to do something like this. You can just ask it from the subviewport itself, what is your path, and this is actually gets a texture. So yeah, this creates a texture for you. I said it wrong, it doesn't give you the path, it creates a texture for you. Let me just get back. Which one was it? Letter. Here it is. So now the image is on the mesh. So basically we've done this. We got our image on the map. Currently I don't have anything under the subviewport, that's why there's this empty texture. So let me show you next how this pickup system is implemented. So first of all, I have this onInteractable interactor. This is part of my interaction system. It might be another function for you. But this is the function that when the player clicks on the letter. And what happens is, first of all, we check if the letter is being picked up. The reason we do this is so that the player can just spam the interact button and the paper might glitch out or something. So we stop this by checking that if we're already interacting, then we return. And then we set the interacting to true. So if it's the first time running, the interacting is false, it will go true, and we set the interacting to true. Once the interacting is true, this will block any other spamming. And then once we're done, we set the interacting to false. Next, what happens? Well, I'll talk about this later. First of all, we check whether or not the letter is picked up or is on the ground. Let's see what's the case when we're on the ground. When we're on the ground, of course we set the is picked up true because we just picked it up. First of all, you don't have to worry about this. This is something specific to my shader. First of all, we get the position where we want to translate our letter to. So in my case, I want it in front of the player. So I get the position of I get the player itself. I get the position of the player's head. And here I just said that the player can't move while he's reading a letter. And I set his velocity to 0. So if he picks up the letter and he's moving at the same time, he doesn't just glide off the screen and things like that. Next, we calculate this desired global, so where we would want to move this letter. And basically we do a translation. So we take the player's camera and translate it. Well, I just asked Gemini because I also didn't just write this just by myself. I had to look it up. So what this line does, let me see. So here it is. This line basically does a translation. So it takes our input vector, which is this. This means that 0 position, so it doesn't go, so basically it's in front of the player, but it's offset by 0.2 units, I don't know, inches, something, from the face of the player. So it's not right in the face of the player, but offset a little bit. And we change only the z-axis, so in front or behind the player. So we move it a little bit in front of the player. And we don't want to change the other axes. And then we multiply the rotation matrix of the camera. Basically, this line, that I was trying to show you, this line does something like this. So it takes the camera's position and it returns a new position. It adds to the camera's position this well, translated version of the position. To be honest, I'm not exactly sure what's going on here. If you want to learn more about this, there is a great playlist by Tree Blue One Bound about linear algebra and these matrix transformations. You could look at those if you want to. I should also probably rewatch those. But basically, by doing this, we get the position where we want our letter to be at. So this moves our letter in front of the player. Next up, we rotate it by 90 degrees. The reason is that when we move the letter, it moves like this. So if you look at my camera, the letter, let's say this is the table, the letter is on the table. When we rotate it, it goes like this. So it's like this, the sharp edge facing the player. So we need to rotate it 90 degrees so that it's facing the player. First of all, we create this, well, we rotate an identical matrix by 90 degrees, and then we apply that rotation to this desired global position that we just calculated here. So we rotate the letter by 90 degrees. We do another rotation, because when the first time I did this, it was like the letter was upside down, so I needed to flip it again. And then, what are we doing? Well, we scale it. We scale the paper down, because, let me just show you, let me just run the script again. What was happening is, when I didn't scale it down, sometimes the letter would clip through, for example, the table or the chairs or something like that, and it would look ugly. So let me just show you. And if you're interested, this is a horror game I'm making. It's called The Final Shift. It will be soon out on Steam if you're interested. It's now in the review process. If you want to be updated, you can leave a comment, and I'll leave another comment for your comment once it's out. But the trailer of the game is already out. You can check that out if you want to. So as you can see, it moves in front of the player, but you see it's scaled down. So it's a little bit smaller, because before it was huge. So it was like, let me see, it was like this big. And when it was that big, it would a lot of the times clip through the walls or to the tables. So it's a good idea to scale the paper down. And since it's in front of the player, he won't notice that it's really tiny actually. So that is why we scale the paper down. The way we do this is by, well, we take the basis vectors of this position and we just scale it by some constant. To be honest, I don't quite remember what I wanted to do here, but just multiplying by a constant or an exported variable does the job. Then we tween that position so it's smooth. So it doesn't just teleport in front of the player, but it moves in a smooth way. So we take the global transform of this letter, we move it to the desired global in some amount of time. And we also can set some kind of, transitions, ease out, ease in, something like that. And this is how we get the letter to be picked up. And putting it back down is much more easier. You basically just take its original position, so where it was before we picked up, and this is why we have this here. So we see, we check if have we already saved the original position. If not, we just save it, so we know where we have to put it back down. Once it's saved, so first of all we check if the letter is picked up, we have to put it down. So is picked up becomes false. The player can move now. This is something specific to my game. We create another tween, we take the global transform and put it back to its original position, and that's it. So yeah, that's basically it, really. Now let me show you a little bit. Now let me just show you the whole code. Maybe it's a little bit too small, but I'll scroll through it again if you want to copy it or just see it. So here is the code. Okay. Next, let's look at this letter text control node. For this to work, you need a control node as a root node. This color rect is the background of this A4 paper. You can also copy the pixel dimensions if you want an A4 paper, otherwise you have to recalculate these. We have a rich text label. The reason I chose the rich text label is so that we can have these different kind of stylings. And in this script, there's not a lot going on. I just have a set text function. If I want to, basically this is what gets called here. Let me just show you. Where is it? Letter here. So this set text function gets called here. So this is the function that's called on the control instance, and this set text function is defined here. And basically that's it. I also done something like this where let me just show you. For example, here in this specific case, I have this date, and I want to replace this with the current date. So what is today's date? And the way I've done this is, let me just find it where I've done it. Here it is, a swap text function. So I type in what to find and the new string I want to change it to. So for example, I would call this like swap text, for example, the date, just change it to today's date. Of course, you need to fetch today's date, the actual date, and replace it with that. So what this does, first of all, this is just a safety check to make sure we don't have any errors, and then we just call the set text function where we replace in the text the what to find section with the new string. So that's basically it. And yeah, that's about it for the video. If you have any questions, leave them in the comments. If you're interested in the game I'm making, leave a comment, ask any question that you want. The trailer and the Steam page will be in the description once it's through the review process. And yeah, oh, and also I forgot to mention that let me see, I also have this, so you see that the paper is kind of grainy, it's not just a basic color. This is done through a shader, so you can set a shader for the color rect under the materials section, and this is the shader code I use. I didn't write this was generated by AI. Well, I kind of looked through it, it's not that complicated. I took out the vignette part, not useful for my purposes. You can comment it out if you want to. Let me just zoom in if you want to copy it. this is the shader that you can set a nose texture to it, a base color, and you know, by changing these parameters you can achieve some pretty cool looks. So yeah, that's about it for the video. If you have any questions, leave a comment, and yeah, see you in the next one.